At this stage of the course, you have covered a rich and dense set of topics, from the Open Systems Interconnection model and its 7 layers, to the Address Resolution Protocol, and the Dynamic Host Configuration Protocol, the Network Address Translation Mechanism, the Domain Name System, transport protocols like Transmission Control Protocol and User Datagram Protocol, and application layer protocols like Hypertext Transfer Protocol. Before moving forward into penetration testing and DevSecOps practices, it is essential to consolidate everything you have learned. This chapter focuses on how to review effectively, what personal strategies to adopt, and which resources are best suited to reinforce your understanding as a beginner transitioning into cybersecurity. Why reviewing actively matters more than rereading. Many learners fall into the trap of passive review. They reread their notes, skim through a summary, and feel a false sense of familiarity. This is not consolidation. In a professional context, especially in cybersecurity, you need to be able to apply concepts under pressure, in real environments, with real tools. Passive rereading trains recognition, not recall. The goal of a good review strategy is to train recall and application. Active recall means testing yourself before you feel ready. It means closing your notes and trying to explain, from memory, how a domain name system lookup works step by step. It means drawing the Open Systems Interconnection model from scratch and labeling each layer with its role, its associated protocols, and a real-world example. It means walking through what happens when a browser sends a request to a web server, at every layer of the stack. Spaced repetition is the second key principle. Instead of reviewing everything in one long session the night before a quiz, you review a topic once, then again 2 days later, then again a week later. Each time, the material becomes more deeply embedded. Tools like flashcard applications, such as OnKey, which is free and widely used, are specifically designed to implement spaced repetition automatically. How to structure a review session for network fundamentals. A productive review session for this section of the course should follow a clear structure. Here is a recommended approach. Start by listing, from memory, the 7 layers of the Open Systems Interconnection model: physical, data link, network, transport, session, presentation, application. For each layer, try to name at least one protocol or technology that operates there. Then pick one concept from the list of topics covered, for example, network address translation, and explain it out loud or in writing as if you were teaching it to a colleague. Include what problem it solves, the shortage of public Internet Protocol version 4 addresses, how it works, a router replaces the private source address with its public address and keeps a translation table, and what a real log entry looks like in IPTables. Next, take a concept that connects 2 layers or 2 protocols, for example, how the domain name system interacts with both the User Datagram Protocol, at layer 4, and Hypertext Transfer Protocol, at layer 7, and trace the full data flow. End the session by writing down 2 or 3 questions you could not answer confidently. These become your focus for the next session. Mapping concepts to real scenarios. One of the most effective review techniques for cybersecurity learners is scenario-based mapping. Instead of reviewing protocols in isolation, you place them inside a realistic attack or investigation scenario and ask, what role does each protocol play here? For example, consider this scenario. A security analyst notices unusual outbound traffic from an internal machine. To investigate, they open Wireshark and begin capturing packets. What do they see? At the Ethernet layer, layer 2, they see frames with media access control addresses. At the Internet Protocol layer, layer 3, they see source and destination Internet Protocol addresses. If network address translation is involved, they need to check the router logs to trace the original internal address. At the Transmission Control Protocol layer, layer 4, they see port numbers. A connection to port 443 suggests encrypted Hypertext Transfer Protocol traffic. A connection to port 53 suggests domain name system activity. At the application layer, layer 7, if the traffic is unencrypted Hypertext Transfer Protocol, they can read the full request, the method, GET, POST, the host header, the path, the response code. By practicing this kind of layered scenario analysis, you reinforce all the concepts simultaneously and in context. This is exactly the kind of reasoning you will need as a penetration tester or DevSecOps specialist. Using your previous activities as review material. You have already completed practical exercises that are goldmines for review. Here is how to exploit them. The activity on tracking a network address translation connection with IPTables logs. Go back to that log and try to reconstruct the full connection flow. Which internal address initiated it? Which port was used? What was the destination? Can you now explain what each column of the log means? The activity on solving and sniffing a domain name system lookup. Replay the scenario mentally. A machine needs to reach a hostname. It checks its local hosts file first. If no entry exists, It queries a domain name system resolver. The resolver queries authoritative servers recursively or iteratively. A response comes back with an IP address. The machine then initiates a transmission control protocol connection. Can you draw this from memory? The activity on analyzing an hypertext transfer protocol request in Wireshark. Remember the structure of an hypertext transfer protocol request: the request line, method, path, version, the headers, host, user agent, accept, content type, and the body for post requests. Remember what a 200 response means versus a 301, 403, or 500. The annotated diagram of full traffic from hypertext transfer protocol request to response. Use that diagram as a mental model. Whenever you encounter a new protocol or attack vector, try to place it inside that diagram. Key concepts to master before the quiz. Based on everything covered in this section, here are the critical concepts you must be able to explain clearly. The 7 layers of the Open Systems Interconnection model, their roles, and representative protocols at each layer. The difference between transmission control protocol and user datagram protocol, connection-oriented versus connectionless, reliability mechanisms, use cases. Hypertext transfer protocol uses transmission control protocol. Domain name system queries typically use user datagram protocol. How network address translation works. Private addresses, public addresses, port translation, and the translation table maintained by the router. How the domain name system resolves a hostname. The role of the local host file, the resolver, recursive versus iterative queries, the authoritative name server, and the final response. The structure of an hypertext transfer protocol request and response. Methods: get, post, delete, status codes, 200 OK, 301 moved permanently, 403 forbidden, 404 not found, 500 internal server error, and the significance of headers. How to read a Wireshark capture. Identifying protocols by port number, following a transmission control protocol stream, reading domain name system query and response packets. The role of the hosts file. It overrides domain name system resolution locally, which is useful for testing but also a vector for manipulation and attacks. Recommended tools for self-review. The following tools will help you review and deepen your understanding in a hands-on way. Wireshark. Reopen any captured traffic file from your previous activities. Try to identify every protocol present, trace a complete connection from three-way handshake to response, and spot any anomalies. The command line. Use neslookup or dig to perform domain name system lookups manually and observe the output. Use curl to send raw hypertext transfer protocol requests and read the response headers. Draw.io or any diagramming tool. Redraw the Open Systems Interconnection model and insert your own protocol examples at each layer. Add a realistic data flow, for example, a login form submission, and trace it across all layers. A simple flashcard set covering layer names and numbers, protocol names and their associated layers, port numbers for common services, 80 for Hypertext Transfer Protocol, 443 for Hypertext Transfer Protocol Secure, 53 for Domain Name System, 22 for Secure Shell, 21 for File Transfer Protocol, and definitions for terms like encapsulation, datagram, frame, socket and segment. Managing knowledge gaps without panic. It is normal, at the beginner level, to feel uncertain about certain concepts. The goal is not to memorize everything perfectly but to build a solid mental model that you can refine over time. When you identify a gap, for example, you are not sure exactly how a domain name system response is structured in a Wireshark packet, do not simply reread the theory. Instead, capture a live domain name system query on your machine, open it in Wireshark, and examine the packet yourself. This kind of active exploration is far more effective than passive reading. If you struggle with the connection between layers, remember this simple mental anchor. Data travels down the Open Systems Interconnection stack on the sender's side, from application to physical, is transmitted across the network as bits, and then travels back up the stack on the receiver's side, from physical to application. Each layer adds a header when going down, encapsulation, and removes a header when going up, decapsulation. This single concept unifies almost everything you have learned in this section. Preparing specifically for the quiz. The upcoming quiz will test your ability to identify, explain, and apply the concepts covered in this section. Expect questions that ask you to match protocols to layers, identify what a specific Wireshark capture shows, explain the steps of a domain name system resolution, interpret a network address translation log entry, or describe the difference between transmission control protocol and user datagram protocol in a given scenario. To prepare effectively, do at least 2 full recall sessions before the quiz, one today and one the day before, using the scenario-based and layer-by-layer approaches described above. Review your previous quiz results to identify which topics caused errors, and focus your energy there first. Finally, remember that the goal of this entire section is not just to pass a quiz. It is to build the foundational knowledge that makes you dangerous as a penetration tester and rigorous as a DevSecOps specialist. Every protocol you understand deeply is one more tool in your hands when you are analyzing a real application for vulnerabilities, building a secure delivery pipeline, or explaining a finding to a client in a vulnerability report.